Hello my dear students, welcome back to my class of organic chemistry. This is the lecture number 2 in continuation to my previous lecture. In the last lecture we have studied chapter number 10, that is haloalkanes and haloarenes. We have already studied what are haloalkanes and haloarenes. Today we'll start a new topic, that is nomenclature of those haloalkanes and haloarenes. Nomenclature means naming of the organic compounds. So today we'll take some examples of haloalkanes and we'll name them. First of all, let us take one example: CH3, CH2, CH2, Cl. This is a molecule, that is haloalkane, where you have this one is your alkyl group and this is your halogen. Okay, so this is an alkyl halide or haloalkane. So while naming the organic compound in the HS first year, you have studied some rules are there we have to follow. So first one is we have to identify the longest carbon chain. So this is a simple molecule. So here this is the longest carbon chain, and next is we'll number them. So we'll number those carbon. So numbering start in such a way so that the halogen group or the functional groups get the lowest number. That means 1, 2 and 3. By doing so, the halogen gets the carbon containing halogen gets the lowest number. So from here we can see there are 3 carbons are there. So in naming there are 2 types of name, that is one is called common name and one is IUPAC naming. IUPAC, International Union for Pure and Applied Chemistry. So the common name of this compound is N-propyl chloride. Normal, that is this is your propyl group, 3 carbon. For 3 carbon we use the word prop, and since it is an alkyl group, so it is propyl. Means from the propane one hydrogen is removed, so it is propyl. N-propyl, and halogen is your chlorine, so it is chloride. So N-propyl chloride is the common name. Now in IUPAC naming, first we have to identify the longest chain, then we have to number it, and then we have to name it. So in IUPAC naming, this halogen comes as prefix, that is before the name, and the main chain, since it is an alkane, so this will be the suffix. So we'll write this. First we have to write the position of the halogen. So it is the first carbon, so we'll write 1. Then we'll put one hyphen. Then which group is there? Chloro group. So 1 chloro. Next, how many carbons? 3 carbons. So for 3 carbon we write prop. And since it is an alkane, so we use the word letters ANE. So 1 chloropropane is the IUPAC name of this compound, this molecule. Similarly, we'll take another example. CH3, CH, CH3 and Cl. So this is also your propyl chloride. Since 3 carbons are there and 1 chlorine is there, so it is propyl chloride. But here the chlorine is at the secondary carbon, second carbon. So it is, the common name is isopropyl chloride. This is the common name, but while naming in IUPAC, that is standard form, then we have to, this is the longest chain of carbon, and next we have to find the position of the chloro group. So chloro is in which group? That is 1, 2, 3, second position. So we'll write 2, then 1 hyphen, then which group? Chloro, and since 3 carbons are there, so it will be propane. Okay, like we can name the compound. Now we'll take some more examples. Just I am taking another example. For bromine, let's take bromine. Suppose this is a molecule. We have to name it in IUPAC nomenclature. So first thing is to identify the longest chain. So from it is clear, if we go in this direction 1, 2, 3. If we go in this direction 1, 2, 3, 4. So this is the longest carbon chain. So we have to number it. The second step is we have to number it. So while numbering, we should keep in mind, we should number in such a way that halogen or the functional groups gets the lowest number. That means if we number from here 1, 2, 3 and 4. Okay, so this the numbering is done. Next we have to write the name. So while writing, you see this bromo group will come as prefix, and if there is branching, it also come as prefix. So that means at the first position there is bromo group, and at the third position there is methyl group. You have bromo group and methyl group. So while writing, we have to consider it alphabetically. So alphabetically bromo comes first. So we'll write it first and then we'll write methyl. So how we will write it? 1 bromo, that means at the first position there is bromo, then another hyphen, then methyl group is at which position? Third position. So we'll write 3, again hyphen, then methyl. So prefix is over. Then we have to consider a chain. So how many carbon? 1, 2, 3, 4 in the main chain. So for the 4 carbon, we use the word bute. Bute, and since it is an alkane, so we use the ANA. So 1 bromo 3 methyl butane is the name of this compound. Like this, we can name the haloarene also. So this is your arene, and one hydrogen of that is benzene is replaced by bromine, so it is a haloarene. So the common name is bromobenzene, and IUPAC name also we have to, this the numbering 1, 2, 3, 4, 5, 6. So at the first position there is bromine, so we can write 1 bromobenzene or simply bromobenzene. Similarly, if there are 2 groups are there, suppose one at here and one at here. So for this molecule, you can write the common name is meta dibromobenzene. Means This is the first position. The next position, position number second, is called ortho, and third position, this is ortho, this position is meta, and this position is para. So one is at the first position, bromo group is there, and at the meta position another bromine is there. So meta position, then dibromo first, and at meta position bromo is there, so dibromo, di for 2 bromo group, so dibromo, and the main, that is carbon, is having benzene, so it is meta dibromo benzene. This is the common name, but if you want to write in IUPAC nomenclature, that is standard form, so we have to mention the position as this is your first, second, third, fourth, fifth, and sixth. So bromine is at 1, comma, since both are same group, so they are their position is separated by a comma. So 1, 3, then hyphen, then we write dibromo benzene. 1, 3 dibromo benzene. So like this we can name these compounds, haloalkanes and haloarenes. Next is another thing we have to keep in mind. Just I'm taking one example. Actually in your chapter mainly we have to study about mono, haloalkane or arene, but here we are taking one dihaloalkane. Since 2 hydrogens are replaced by 2 chloro, that is halogen group 2 chloro group, so it is called dihaloalkane. I have taken this one to make you understand that in this molecule 2 hydrogen of the same carbon are replaced by the halogen. That is 2 hydrogen are replaced by the 2 chlorine from the same carbon atom. So these are called alkylidine. Alkylidine and ethylidine. These are called ethylidine, and if one hydrogen from this carbon and one hydrogen from this carbon are replaced by the halogen, then they are called ethylidine and ethylene. Okay, so ethylidine and ethylene, and ethylidine, since 2 chlorines are there, so it is called ethylidine in this form. It is called ethylidine chloride. If from the same carbon 2 hydrogen are replaced, then called ethylidine chloride, and if 2 hydrogen from 2 different carbons are replaced, then called ethylene dichloride. So this is the basic difference. I am again repeating, if from the same carbon 2 chlorines are 2 hydrogen are replaced, then it is called ethylidine chloride, and if 2 hydrogen from 2 different carbons are replaced by the halogen, then it is called ethylene dichloride. It is also called geminal dihalide, and if from different carbon hydrogen is replaced, then it is called vicinal dihalide. Geminal dihalide and vicinal dihalide. Okay, hope it is clear to everyone. So this is all about nomenclature. Next topic is nature of CX bond. nature of CX bond. For example, CH3, CH2, Cl. So we can see in haloalkane or haloarene molecule, there is a bond between carbon and halogen. Carbon and halogen. So we have to study about that bond. So in this bonding, you see this is your carbon atom and this is your halogen atom. And we know halogen atoms are more electronegative than carbon. That means the tendency to pull the shared pair towards itself is known as electronegativity. So it is more electronegative than carbon, and as a result this gets partial negative charge and it acquires partial positive charge, delta minus and delta plus. Is it visible? It acquires delta negative and it acquires delta positive charge. That means polarization of the bond takes place. Negative pole and positive pole. This is called polarization of the bond. That means CX bond in haloalkane is polar in nature. Now what happens? You see, CX, this is the bond length, means the bond length, you know, the distance between the two nucleus of two different atoms. So we know halogen atoms are fluorine, chlorine, bromine and iodine mainly we consider. So as we move from fluorine to chlorine, bromine and iodine, the atomic radii increases. That means size increases. Suppose this is the size of fluorine, then chlorine will become bigger, then bromine, then iodine, like this. This goes on increasing. So since the atomic radii increases, as a result the distance between two nucleus also increases, and the distance is called bond length. So suppose this is the bond between carbon and fluorine, carbon, chlorine, carbon, bromine and carbon iodine. So as we move from top to bottom, that is bond length, what? Bond length increases. So as we move downward, the CX bond length increases because the size is increasing. Is it clear? Now you see another parameter is bond enthalpy. Bond enthalpy means nothing. It is the energy required to break a bond. Now you see, suppose in carbon and fluorine, this is carbon and this is fluorine. So this is the distance between these two, that is the bond length. Now this is carbon and this is fluorine. So since bond length is shorter in case of carbon fluorine bond, so they are more closely packed and the electronic attraction is more in case of carbon and fluorine than that of carbon and fluorine. So breaking will be easier in this case as compared to this one. Is it clear? So the bond enthalpy for this will be more and this will be less, and it goes on decreasing. So as we move from top to bottom, the bond enthalpy decreases. Is it clear? Okay. So this is about CX bond of haloalkanes and haloarenes. That means bond length increases as the halogen atom changes from fluorine to iodine, and bond enthalpy goes on decreasing. Is it clear? Next topic is preparation of haloalkane. preparation of haloalkane. So in preparation of haloalkanes, different methods are there. We can prepare haloalkane from different starting materials. The first one is that of from alcohols. First one is from alcohol. All of you know what are alcohols? Alcohols are those compounds which are having the OH group. OH functional groups are called alcohols. For example, CH3OH, C2H5OH, that is methanol, ethanol, all are what? Your alcohols. They are represented by general formula ROH. R stands for alkyl group and OH for hydroxy group represents alcohol. So these are the general formula for alcohol. Now you see from alcohol how we will prepare the haloalkane. ROH, this is your alcohol. Okay, we have taken general formula. So first one is, if we react it with halogen acid. Halogen acids means HCl, HF, HBr, all are called halogen acid. They are represented by HX. H and X, that may be fluorine, chlorine, bromine, iodine. So these are called halogen acid. If we react an alcohol with halogen acid, one condition is there. Here we have to use a catalyst, zinc chloride, ZnCl2, which acts as a catalyst. Then what happens? This OH group is replaced by your halogen. So it will become RX, that is X will replace OH. It is a nucleophile, X negative and H positive. So X negative will replace OH negative from here. So it will replace OH and form RX. And this OH, when it breaks as a OH negative. This OH negative will take H positive from here and it will form water. So by this way we can prepare haloalkane or alkyl halide. This is your alkyl halide. For example, suppose CH3OH plus HCl. So what will happen? This Cl will replace OH. It will become CH3Cl plus H positive from here, OH negative from here. They will combine together to form water. So this is one way, that is from alcohol. When we react halogen acid, it forms in presence of zinc chloride, it forms alkyl halide. Next is, if we react alcohol with, that is phosphorus trichloride or phosphorus pentachloride. This is phosphorus trihalide or phosphorus pentahalide. First we will take phosphorus trichloride. So in this case, this R, that is OH replaced by Cl, one Cl from here, so it forms RCl plus, for this we have to balance it. That means we have to take 3 molecules of alcohol. So it will form 3 RCl plus, how many hydrogens are remaining? 3 hydrogen, 1 P and again 3 oxygen, H3PO3. That means when we react alcohol with potassium, phosphorus trichloride, it forms 3 molecule of alkyl halide plus phosphoric acid is released. Okay, so this is another method by which we can prepare alkyl halide. In each case, you can replace R by CH3, C2H5 like this, C3H9, C3H7. These are alkyl group. Okay. So this is another method. Also, we can prepare if we take PCl5, phosphorus pentachloride. So again, we will get RCl plus PO and Cl3, okay, plus HCl. Now it is okay. That is 1 R. Will take 1 Cl from here, it will form RCl plus remaining P and O from here and 3 Cl from here, it will form POCl, phosphoric chloride, plus 1 molecule of hydrogen chloride, HCl will be released. Another way we can prepare is by reacting it alcohol with thionyl chloride. What is thionyl chloride? Thionyl chloride is SOCl2. So this is called thionyl chloride. So if we react alcohol with thionyl chloride, then it forms RCl, OH is replaced by Cl, plus sulfur dioxide, SO and 1 O from here, it will form sulfur dioxide, plus HCl, remaining H and 1 Cl from here will form HCl. One of the merit of this reaction is that it is preferred because in this case SO2 formed is a gas and HCl is also in as a fumes, as a gas. It leaves the place, means it evaporates. So remaining RCl we can easily take out. Okay, easily we can take out this RCl from the container and these two escapes to them. So this method is preferred, that is reaction of alcohol with thionyl chloride. Okay. These are some of the methods by which we can prepare the alkyl halides. Next topic is, okay, before going to the next method, one more thing we have to consider, that is reactivity of suppose in the first case we have taken alcohol plus HX, halogen acid. Reaction of alcohol with halogen acid. One thing matter, this one is your primary alcohol. The alcohol may be primary, secondary and tertiary. All you know what are primary alcohols, means OH group is attached to that carbon in which there is only another carbon, one carbon is directly bonded. As for example, CH3, CH2, OH. In this alcohol you see OH is bonded to this carbon and this carbon is directly bonded to only one carbon, remaining two are hydrogen. So that is primary alcohol. In the secondary alcohol, I am taking one example, CH3, CH2, C. Now see, in this case, this OH is bonded to this carbon and this carbon is directly bonded to one carbon and two carbon and one hydrogen. So this is a secondary carbon and this becomes a secondary alcohol. Similarly, tertiary alcohol is so this is the OH group is attached to this carbon and this carbon is directly bonded to three different carbon atoms, so it is a tertiary alcohol. So what we have to see, the reaction of alcohol with halogen acid, the reactivity is tertiary is more reactive than secondary and than primary. That means tertiary alcohol easily reacts with concentrated halogen acid. But in case of primary and secondary, we have to use the catalyst. As we have already seen, we have used which catalyst? That is zinc chloride, ZnCl2. Hope it is clear to everyone. So this is all about today's lecture. In the next, we'll further continue with the other methods of preparation of alkyl halide. So take care. Thank you.